Okay guys, are you ready for some more fun? So here's where we're at. We have now learned the 6 trig definitions: sine, cosine, tangent, cosecant, secant, cotangent. We have learned, depending on what quadrant the right triangle is drawn in, is whether the answer for the trig function is positive or negative. We've learned now that if you have a quadrantal angle, an angle that's a multiple of 90, you can look up its exact value. We learned if you have a special angle that's 30, 45, or 60, you can look up its trig function's exact value. Well, to finish up and continue on with this idea, there are other angles besides quadrantals, 30, 45, and 60, that you can look up the trig function value. Okay? And you can do all this by drawing pictures. Today we're going to talk about something called a reference angle. The definition of a reference angle is always located in quadrant 1. So a reference angle, if it's always located in quadrant 1, how many degrees can it be? Well, it's got to be between 0 and 90 if it's in quadrant 1. So any angle that's measured is between 0 and 90 is called a reference angle. So is 150, 210, 330 degrees, are those reference angles? Heck no, they are not in quadrant 1. What we are going to learn today is if you have an angle bigger than 90, which these are, they're all bigger than 90, you can find its reference angle. You can find out what angle in quadrant 1 these correspond to. I'm going to do this visually by drawing pictures. So we're back to, hey, do you know how to draw a 150-degree angle in standard position? Yes, put your vertex point. Put your initial ray. 150 degrees means the terminal side would be in quadrant 2. We know from here to here is 150 degrees, correct? If that terminal side lands in quadrant 2, we know we could drop a perpendicular and make a right triangle, correct? Everybody look at me. Can you tell me exactly how many degrees that angle is? Sure you can, because you know if you went from quadrant 1 all the way to quadrant 2, how many degrees would that be? 180. Well, if you only gone 150 degrees, you know this missing angle in here has got to be 30 degrees. 30 degrees is between 0 and 90. 30 degrees is your reference angle. So if I want to look up the sine, cosine, tangent of 150 degrees without a calculator, because we haven't learned how to do that yet, really, we don't need a calculator because its reference angle would be 30 degrees. And we learned in the previous video how to look up the sine, cosine, tangent value of 30 degrees. So every angle that's bigger than 90 has a reference angle. If I had 210 degrees, how would I find its reference angle? Visually, we draw the angle. We'd say, okay, there's my vertex, there's my initial ray. 210 degrees is in quadrant 3. That's where the terminal ray would land. So we know from here all the way to there is 210 degrees. You with me? We know how to draw a triangle in quadrant 3. We drop our perpendicular. So the question is, how many degrees is this angle, acute angle, inside the triangle? Well, we know from here all the way, from the initial ray all the way to the terminal ray is 210 degrees. We also know from here the initial ray all the way to there is 180. So if the whole thing's 210 and from here to here is 180, do you agree missing right here is 30 degrees? That is your reference angle. So if I'm going to ask you to look up the sine, cosine, or tangent value of 210 degrees, you're going to have to use 30 degree, the 30-degree triangle, because that's its reference angle. Visually look at the picture. All right? If I drew an angle that was 330 degrees, here's my vertex. Here's my initial ray. 330 degrees would be in quadrant 4 would be the terminal ray. So if I'm going from here counterclockwise all the way to here, we know that's 330 degrees. If our terminal ray lands in quadrant 4, we know here's our perpendicular, there's our right triangle. Can we find out how many degrees is in that acute angle of that right triangle? Well, sure we can, because we know if we start here on the initial ray and if we went all the way around in a circle, that would be 360. But if we only go from here to here, 330, there's got to be another 30 degrees missing. So if I wanted to look up the sine, cosine, or tangent value of 330 degrees, I'm really looking up 30 degrees. That's its reference angle. A reference angle is always an angle that's between 0 and 90. These are all 30 degrees, 30 degrees, 30 degrees are all between 0 and 90. Now, let's think about this. Are we really going to have to draw a picture of all these angles to figure out what their reference angles are? No. There's an algebra. There's a formula. There's a rule we can come up with. So let's look here. Another thing you're going to have to memorize. I know I'm throwing a lot at you in this chapter, but this is the beginning of trig. Trig has a lot of definitions. If you memorize your definitions, you got it made the rest of the semester. So this angle is 150. It was in quadrant 2. Its reference angle was 30. How did we make 150 become 30? Well, what we did is we said, if you take 180 and subtract 150, you get 30. Does that make sense? If an angle is drawn in quadrant 2, we know it's going to be less than 180 degrees. So the reference angle rule is 180 degrees minus your angle theta. So if our angle is 150, 180 minus 150 would give me that 30 without having to draw the picture. Memorize that. If I want the reference angle for quadrant 3, well, again, let's look. We started with 210, and we got a reference angle of 30. What we did is from 210, we took away 180. 210 minus 180 would give us 30, right? So this rule is theta minus 180. If your angle is in quadrant 3, it's going to be bigger than 180. So if we subtract 180 from it, we'll get this angle in the right triangle. All right, look here. We had 330, and we got the reference angle of 30. How did we do that? Because we said if we went all the way around, it would have been how many degrees? 360. And if we subtract the angle I gave you, 330, 360 minus 330 would be 30. These are your reference angle rules. You need to memorize them. There is no rule in quadrant 1 because, again, how many degrees is an angle in quadrant 1? Between 0 and 90, and that is a reference angle. You can't get any lower. The problem with using these rules is, to use these rules, your angles have to be bigger than 90 and less than 360. Okay, so let's talk. Let's go to examples 2. 2A, B, C, and D. We're going to do all 4 because they're quick. It says, give me the reference angle. So 240 degrees is in which quadrant, people? 240 degrees is in quadrant 3, right? The reference angle rule is theta minus 180. So we're just going to do in our calculator 240 minus 180, and it's going to give us 60. So if I drew a 240 degree angle, the triangle in quadrant 3 would have an angle here of 60. That's your reference angle. If I want the reference angle to 315 degrees, what quadrant are we in? Well, we know 315 degrees is in quadrant 4. The rule is 360 minus theta. So 360 minus 315 is 45 degrees. If you drew a 315 degree angle, then this angle inside the triangle would be 45 degrees. Because if I went around 315, I'd have 45 to go to make a circle. So these fit the reference angle rules beautifully. C and D do not. Because to use these rules, the angle cannot be negative, and the angle cannot be more than 360. So you're going to say, well, how do I find the reference angle if I can't take these angles and plug them into the formulas, substitute them in because I can't use the rules? You got to use what we've learned before. Every angle in trigonometry has another angle that lands in its same position. What was that called? Coterminal. How do you find coterminal angles? You either add or subtract 360. So to find a reference angle, the first thing we got to do is make this positive. How do we make negative 210 positive? We add to it 360. And that would give us 150 degrees. Do you agree with that? What quadrant is that in? Oh, that's in quadrant 2. So in quadrant 2, the reference angle rule is 180 minus theta. So 180 minus 150 means my reference angle would be 30 degrees. That's saving you guys a lot of time. I'm saving you from making you draw an angle that's negative 215 degrees, drawing the triangle, making that positive, and find out what the angle is inside the triangle. That's what I'm trying to show you. I could do it for you. If I said draw me a negative 210 angle from the beginning of the semester, I would go clockwise because I'm going negative. So this would be negative 90, negative 180, negative 270. I know I'd land in quadrant 2. If I go back negative 210 degrees, y'all with me? That would be like going forwards 150 degrees, right? Because 210 and 150 would make the 360. And if that's 150, this has got to be 30. Because altogether it's got to be 180. Instead of you doing all that thinking, just memorize the rules. But to use these reference angle rules, this angle's got to be positive. So that's why we had to learn about coterminal angles. This angle, 1250 degrees, is way too big. You can't use these rules. To use these rules, the angle has to be bigger than 90, less than 360. So the problem is we got to get this smaller. Well, how do you get this angle smaller? You don't add 360. You subtract 360. Now the question is, how many times would you subtract 360? This is why calculators are lovely, handy. If you subtract 360 once, that's going to give me 890. That's not good enough. If I subtract 360 twice, I'm going to get 530. That's not good enough. If I subtract 360 3 times, I get 170 degrees. So we know about if you add or subtract 360, you're going to get angles that land in the same spot, coterminal. So really, looking up 1250 degrees would be the same thing. Drawing that angle would be the same thing as drawing 170 degrees. Their terminal rays would land in the same spot. What quadrant is that in? 2. So to find its reference angle, we do 180 minus theta. 180 minus 170 would be 10 degrees. That's its reference angle. So think about it. If I drew an angle in quadrant 2 that went from here to here, that was 170 degrees, that angle there would have to be 10 degrees. Everybody's good? All right, now that you know how to get a reference angle, here comes the fun. This is the part I love the most. This is my favorite part, evaluating. Find me the value of these trig functions, not using a calculator. Because again, the calculator is going to give you these ugly decimals, and we're not going to accept them. You've got to know how to do this by hand. So, I'm going to erase this, and we're going to get working. Now, to evaluate trig functions, you're going to need a lot of information. First of all, you're going to need your special right triangles and your unit circle. So I'm going to draw them all here. I know my unit circle, 1, 0, 0, 1, negative 1, 0, 0, negative 1. And I know this is if I have angles that are 0, 90, 180, 270, 360. If you need to write that down, write it down. You're going to need your triangles. There's the 45, 45, 90, where the sides are 1, 1, square root of 2, because I have that memorized. There is the 30, 60, 90. So if you put the 30 degrees here and the 60 degrees here, opposite the 30 is 1, opposite the 60 square root of 3, the radius is 2. Or you can draw it where the 60 degrees is here, which makes the 30 degrees here. Opposite the 60 is square root of 3, opposite the 30 is 1, 2. You also need to remember your catchphrase, all students take calculus. So look at me. This is all stuff that's memorized. Now when I do my homework and do my trig test, I have this all written down. I write it down, so before I even start, I have it in front of me. But it's got to be memorized. I'm not going to give it to you. You have to know all this. Okay? For your final exam, you're going to have a blank slate. You're going to have to know all this. Okay? So if I want to know the cosine of 315 degrees, all right, first thing is I have nothing up here that shows 315 degrees. I can only look up quadrantal angles, 45, 30, and 60 without a calculator. So the first thing I got to do is get a reference angle. So what quadrant are we in? 4. Let's get the reference angle. The reference angle would be, for this, 360 minus 315, which is 45 degrees. So when you write the cosine of 315 degrees, you're really looking up the cosine of 45 degrees. Y'all with me on that? Now, I know how to look up the cosine of 45 degrees. I come over here to my 45 degree angle, and I know my cosine value is x over r. So I know the cosine of 45 is 1 over square root of 2, which is unacceptable. That rationalizes to square root of 2 over 2. Everybody's good with me so far? All stuff. Here's the problem. The angle I gave you didn't start out as 45. It started out as what? 315. You have to use this original angle. What quadrant is this angle in? It's in quadrant 4. In quadrant 4, is cosine positive or negative? Well, C means cosine is what, y'all? Positive. That would be the answer. So that is evaluating. I gave you an expression. You gave me out its value. But to get out this value, you have to use all your components here. Let's try the next one. Let's do 3D. Let's look at the cosine of 570 degrees. Well, I have nothing up here that shows 570 degrees. All right. It's way too big. I can't even use these reference angle rules yet till I get this down. So how do I make this angle smaller? What do? Good, I'd use my idea of coterminal. I subtract 360. So this is the cosine of 210 degrees. All right. What quadrant is 210 degrees in? Oh, it's in quadrant 3. Now I can get its reference angle. The reference angle is 210 minus 180. 210 minus 180 would be 30. So looking up the cosine of 210 degrees is going to be the same thing as looking up the cosine of 30 degrees. So I can look up the cosine of 30 degrees because I have a triangle. If I'm looking up 30 degrees, I'm looking here at the 30 degree. Cosine again is x over r. So the cosine of 30 degrees is square root of 3 over 2. But that was not our original angle. Remember, the reference angle is always going to be in quadrant 1. You have to go back to the original. The original angle was 570. But we know 570's ray, terminal ray, is going to land in the same spot as 210's terminal ray, because that's what coterminal means. They land in the same spot. What quadrant is that in? 3. So think about it. If you went 570 degrees, you would go all the way around. That'd be 360. Here would be 450. This would be 540. So 570 would be here in quadrant 3. In quadrant 3, is cosine positive? No, T means tangent's positive, which means this final answer is what, y'all? It's negative. So you would say the cosine of 570 degrees is negative square root of 3 over 2. I could tell you right now where your boo-boos are going to be on your homework. It's not going to be getting on the fraction value. It's going to be knowing whether your answer is positive or negative. Because what you guys are all doing is you're assuming, because we make a reference angle, and that reference angle is between 0 and 90, all the answers are in quadrant 1. You have to go back to the original angle I was given. This is in quadrant 3. In quadrant 3, tangent is positive, which means everybody else is negative. All right, I love E. I love E because you got 3 angles. I got the sine is 60 degrees. Do I need a reference angle? No, I have the reference angle. That angle is between 0 and 90. I can look that up. So I'm going to go to 60 degrees. Got to use this triangle. Sine is y over r, square root of 3 over 2. That's done. Because this angle was in quadrant 1, that should be positive. Every trig function is positive in quadrant 1. I need to look up the cosine of 150. Uh-oh, there is no 150 up here. So to look up the cosine of 150, what quadrant is this in? This is in quadrant 2. So the reference angle rule is 180 minus 150, which would be 30. So I'm really asking you to look up the cosine of 30 degrees. Y'all with me? So I'm going to 30 degrees. Cosine is x over r. So that would be square root of 3 over 2. But remember, the angle was in quadrant 2. 150 was in quadrant 2. In quadrant 2, who is positive? Sine. This is cosine. It's got to be negative. That's where the boo-boo is going to be. Minus, I got to look at the tangent in negative 45 degrees. Okay, what kind of 45 is that? I hate to tell you, that's positive. This is negative. Can't use my reference angle rules. So I got to first make a coterminal angle. If that's negative, I got to make it positive. So negative 45 degrees plus 360, because it's going around in the circle, coterminal, would give me 315 degrees. Now I know what quadrant. I'm in quadrant what, y'all? 4. What's the reference angle? 360 minus 315 happens to be positive 45. So we're really looking up here the tangent of 45. Don't be making up your own rules. Don't be thinking whatever angle is here that's negative, its reference angle is just going to be the positive. Don't do that. Okay? You got to go through the process. We have to make this positive first to know what quadrant it's in. Then we got to know what reference angle to rule. I'm going to look at the tangent of 45. 45 is here. Tangent is y over x. So that would be 1 over 1, which is 1. But remember, we're not dealing with 45 degrees. We were dealing with negative 45 degrees. Negative 45 degrees, terminal ray, would land in the same spot as 315 degrees, terminal ray would land. These two would land in the same spot. In quadrant 4, who's positive? Cosine, which means this tangent value would also be negative. Once you get there, it's arithmetic. This is multiplying. We know how to do that. Multiplying fractions is no problem. Top times top, bottom times bottom. A positive times a negative is a negative. Square root of 3 times square root of 3 is just 3. 2 times 2 is 4. 2 negatives make a positive. What is negative 3/4 plus 1? Or a better way of saying that, what is 1 minus 3/4? 1/4. There's your expression evaluated. It's understanding the concept of trig to understand why this is the answer. Okay, let's do one more. Let's do 3G. Because again, I don't want to forget about angles don't have to be just measured in degrees. This angle is in what? 7 pi over 6 is radians. So I'm going to write it over here. 3G. We have the sine of 7 pi over 6. I want to know what it equals as a number. So the first thing we have to do is what we talked about in the beginning. We don't understand radians very well. We don't like radians very well. Let's just change it to degrees. We could do the trick. We could write 180 over pi, or we could replace pi always with 180 degrees. 6 goes into 180 30 times. 7 times 30 is 210. So writing the sine of 7 pi over 6 is like writing the sine of 210 degrees. Well, there is no 210 degrees over here. I need a reference angle. What quadrant are we in? Quadrant 3. So the reference angle rule is theta minus 180. 210 minus 180 would really be looking up the sine of 30 degrees. That we can do. We can go to 30 degrees. We can do sine. Y over R. The sine of 30 degrees is a half. But I didn't want the sine of 30 degrees. The original angle was 210 degrees. What quadrant were we in? The third. Is the answer going to be positive or negative? In the third quadrant, tangent is positive, which means this answer is negative. So the sine of 7 pi over 6 is the negative 1/2. All right, you have a lot of practicing to do because this is the bulk of what the whole chapter was about. We have one more section to cover in 2.2 that's short and sweet. So I'll see you in the one more video.